this is Mrs. Yanni, and I'm going to talk about the Chapter 5 material. In Chapter 5, we're talking about multiplication of fractions, decimals, and negative numbers. So I just want to start with what I'm going to talk about in this short video. So I'm going to talk about story problems for multiplication. I'm going to talk about why we put the decimal where we do when we multiply decimals. I'm going to talk about decimals in terms of area when we look at an area model, especially in terms of how we would model that using base 10 blocks. I'm going to explain why a positive multiplied by a negative is a negative, and I'm going to give a couple story problem examples. I'm going to talk about scientific notation briefly, and I'm just going to remind you that we're really focusing on the Common Core practices 1, 3, and 6, which talk about persevering in solving problems and justifying our thinking and attending to precision. So let's start. Let's start with the meaning of multiplication. So remember that when we talk about the meaning of multiplication, we're talking about A times B, where A is the number of groups and B is the amount in each group. So if you look at this example of 1/2 times 3/4, and I like to think of that as 1/2 of 3/4, then I can model it this way. So if I'm thinking of it as a half of 3/4, then I'm going to want to think of the initial whole to start with, and then I'm taking half of 3/4, and 3/4 is 3/4 of that initial whole. So that's what I've shown here, is 3/4 of that whole. And then I'm going to show that I'm going to take half of that. And so what I did is I took half of that, as you can see here, but then I've shown a dotted line here so that I can see that really what I'm left with now are 8 parts, and that I've shaded the half as well. So now I'm left with 3 shaded parts out of 8. So I can see that visually we can represent by area that 1/2 of 3/4 is 3/8. Okay, so now let's talk about decimals and multiplying with decimals. So first let's talk about the decimal point. And I'm going to remind you that we should always estimate and then calculate for really any computation that we're doing. But let's talk about this one example. So we have 6 and 24/100 times 12/100. So really we should think about, okay, so I'm taking a little more than 6 times about 1/10. And so reason through that, I'm obviously going to get a number that's a little greater than 6, but not a whole lot greater. And so by estimating that, I'm going to see if my answer is reasonable. And that helps a lot when you're placing your decimal point. If you know what to expect, you'll know that where you're placing your decimal point makes sense or not. But what I've done here is to basically think about multiplying without my decimal point. I'm multiplying 6 and 24/100 by 10 twice, or in other words, by 100. And that removes my decimal point, because I multiply by 10, moves the decimal point to here, multiply by 10, moves the decimal point to here. So now I'm multiplying 624. I'm going to do the same thing with 12/100, multiply by 10 twice, or by 100, and I'm left with 12. And so now when I multiply, I get 7,488. But since I multiplied by 10 twice, now I'm going to divide my answer by 10 twice, and I'm left with 0.7488, which is an answer that, by my estimation, is what I should expect. Let's talk about multiplication of decimals in terms of multiplying fractions, because of course you could think of them that way. So 1.25 times 0.003 is my example. So I'm going to think of 1.25 as 125/100, which we could also think of as 125 over 10 times 10. And then I'm going to think of 3/1000 here as just that, like I said, as a fraction, 3/1000, or 3 over 10 times 10 times 10. And because our decimal system is so slick, this really allows us to then just multiply our numerators, 125 times 3, and look at what happens when we multiply our denominators then. We have 10 times 10 times 10 times 10 times 10, basically multiplying all these 10s, which that's the slick part, because then I'm left with 10 to the 5th, 375 divided by 10 to the 5th, or over 10 to the 5th. So really remember that if you're dividing by a number that's large like that, 10 to the 5th, it's like 375 times 10 to the -5, which means we're going to move that decimal point 5 places to the left. So I'm left with 0.00375. Lastly, I want to talk about multiplication of decimals in terms of area. So I'm going to use 1.4 times 2.8 as the example. So here I have a square, and that's a 1 by 1 square. So here on this side, I'm showing this length as 1.4, 1 whole, and then 4/10. And then this length is my 2.8, so I show 1 whole plus another whole plus 8/10. And so what I'm showing here, by making this array model, and think of this also as our base 10 blocks when we model those, but what I'm showing here is an area of 1. 1 times 1 is 1. So I'm showing an area of 1 and 1. And then if I add up all my tenths, I'm left with 16 tenths, which I know is like 1 additional whole and 6 additional tenths. So now I have a total of 3 wholes and 6 tenths. Plus, I can't forget these little guys here. These are our hundredths, and there are 32 of them. So what I have really is 3 and 6 tenths plus 32 hundredths. So I wrote that in the fraction form here, and now I wrote it as a decimal, 3.6 plus 32 hundredths, and I'm left with 3 and 92 hundredths. So that's a pretty slick way for us to visually represent what's happening when we multiply decimals. And then last, I just want to close the decimal part with a story problem about decimals. Just a simple story problem would be something like this. I bought 8.3 gallons of gas, and each gallon cost $2.15. So how much did I pay for gas? All right. So let's go on and talk about negative numbers now. And specifically why, when we multiply a positive times a negative, we end up with a negative answer. So of course we know that a times negative b is going to give us a negative, whatever a times b is equal to. So for example, 5 times negative 4, if we just think of this as 5 groups of negative 4, we have 1, 2, uh-oh, I left off 4, didn't I? So 5 groups of negative 4, I should have put up here, 4 more. So for a total of 20 reds, or negative 20. So 3 times negative 2, let's talk about that as in terms of owing. We could think of this as I owe 3 people $2. So I owe all 3 of these people $2. So I owe a total of $6. I also like to think of this as modeling it on a number line. So in this case, if we just have a positive times a positive, 3 times 2, we can think of that as taking 3 jumps of 2 forward spaces each. And you can see that that's what I'm doing here, and I end up at positive 6. But if I'm thinking of my negative then as backward spaces or backward jumps, I can take 3 jumps of 2 backward spaces each, and I end up here at negative 6. The tricky part comes in coming up with a real-life model for a negative times a negative. And it's pretty tricky. A lot of times when we talk about owing, it's pretty simple to explain a problem where we have a positive and a negative. You can always say you owe a certain amount to a certain number of people. But when we're talking about a negative times a negative, it does get tricky. So here's one example that might hopefully make sense to you. Negative 5 times negative 4 is what I'm going to talk about. And so if I have a tank of water, and my negative 5 is going to represent the amount that's taken out, or that's leaking out of the tank every day. And then my negative 4 is going to be referring to 4 days ago in my problem. So here's a problem. If 5 gallons are taken out, so there's the negative reference, each day, how much was in the tank 4 days ago? So I'm able to model then how much is taken out 4 days ago. And then of course we know that my answer would be a positive 20. That's where I started in the positive 4 days ago. Or you can think of it, so this is a little bit of a stretch, but let's say that you won this great prize, and the prize is going to pay your mortgage for 1 whole year. And so you want to know how much do you gain in your bank account because of that prize, assuming that all of this was taken care of automatically beforehand. So what you gain in your bank account is you gain a number of groups removed was negative 12 because it's monthly, and negative 700, instead of that being taken out of your account, now you're gaining that amount. So you're gaining the result of negative 12 times negative 700. So it's a positive amount that you have gained by winning that prize. Okay, lastly, I want to talk about scientific notation. And I'm just going to talk about it briefly, but scientific notation is really helpful in understanding our large and small numbers. In fact, it's used most often in applications of the sciences, both life sciences, when we're talking about very small particles, molecules, viruses even. We talk about scientific notation. And then we talk about in physical science, we talk in earth science, we talk about these ginormous numbers, like measuring distance in space. We use scientific notation. So basically scientific notation is what you see here. So here I have 10 to the 6th, and just that expression right there is known as a power of 10, where 6 is our exponent, and that expression simply means multiplying 10 6 times, or 10 times 10 times 10 times 10 times 10 times 10. And so I just want to talk about the correlation between the decimal notation and scientific notation. So in decimal notation, let's just take the number 12. you could write that simple decimal notation as just 12. But if we wanted to write 12 in scientific notation, we could write 1.2. So we always have one decimal point, or one number to the left, I should say, of the decimal point, times the number of times we need to multiply by 10 to get that number. So in this case, we just need to multiply by 10 one time to get 12. So if we have a number like 123, we're still going to put that decimal point here so that there's just one number to the left of 1. But this time, in order to get 123, we're going to need to multiply by 10 two times. 1, 2. So in other words, we're taking 1.23 times 100, or 10 to the second. Same example, or same thing is happening here in this example, 1,234. We are going to have to move the decimal point 3 times, or in other words, multiply by 10 3 times, or multiply by 1,000 to get 1,234. Of course, we can also go backwards. So if we want to represent 0.12345 in scientific notation, we're going to, of course, have one number to the left of the decimal point. And this time we want to move that decimal point one space to the left. And so to do that, we're going to say that we're multiplying by 10 to the negative 1, or 1/10, or dividing by 10. Same thing here. This time we want to move our decimal point 2 spaces to the left. So we're multiplying by 10 to the negative 2, or 1/100th, or dividing that by 100. And then in this case, we're multiplying. We want to move it 3 spaces to the left, so we're multiplying by 10 to the negative 3, which is like multiplying times 1 to the times 1/1000th, or dividing by 1,000. Okay, so I hope that helps for Chapter 5, and if you have further questions, make sure that you ask.